Angular magnification, right? There are two ways. The first thing is you have to focus your final image at infinity. That is the normal adjustment for a telescope, unlike of the microscope. And the second scenario is you have to learn how to derive when the final image is created at D, capital D, that means least distance of distinct vision. Okay, have a good look at. Now you are going to draw a straight line. Don't ever try to remember the diagram. That is carefully how to remember. So just remember the process with logic, then you will never get stuck in the exam. Then you have to draw, first thing is a convex lens like this. It has a focal length of f0 and another convex lens here, that with a shorter focal length, and fi is, and you have to draw certain line just slanted to the first one. Imagine there is the moon. You just draw the first ray, from here, and it does not deviate because it is coming through the arc. The other one you have to draw is from the top of the moon. Right, it reached to here. Now, as you know one thing, normally light rays coming from infinite objects are assumed to having a collimated parallel lines. These are parallel to each other. Then the parallel beams normally focus on focal plane. So any point above or below the focal point is focal plane. On the focal plane, I will just create this image. Have a good look at. Okay. Now the rays will go like this, and it will just create the image of it. So I mark the image height as capital H. Okay, first image. Right. If I want to create a final image at infinity, where should I keep this lens so as to create this one? You have to create it exactly on the focal length of focal point of focal plane of the second lens. So FE is also the same point. So UE is none other than FE, right? This distance, object distance. Okay, you draw a line and you have to measure certain distance similar, and going to draw certain line like this. Okay. The second scenario is you have to draw a line like this. Now I'm going to extend this line back, and you can see it is creating the image at infinity. Right. To make this angular magnification, you have to have certain two angles. Firstly, magnification of the final image at infinity is equals to, for my notation, many people just use alpha over beta, and somebody use beta over alpha. I use beta over alpha case. Okay. My second angle is beta. So beta angle over alpha angle. You might be wondering what is that beta angle. For my case, I take this final angle as beta, second one. That is what you will see through your eye, right? You'll see through your eye. Sorry, it is beta, as I said, beta. It is beta, okay? Right. And alpha is the angle. It should fall on the naked eye when you just observe the moon. Imagine you just observe the moon, right? Your naked eye. It will just create certain angle into your eye. That angle is alpha. So when you just keep here, there is the angle. This one itself. You might be asking, how, sir? The reason is this is the eye. It is targeting at certain object very far away from you. This is the objective lens targeting the same thing. If I keep my eye at there, it will fall the same angle on my eye. So it is the same angle. Can you understand? Same difference of angle. So this angle I identified now. The same angle repeats here because it is the vertically opposite angle. Right. Now I can create another triangle from here. You can see. Now the other triangle is this one, height of h and angle of alpha, and the distance is f0. See, f0. not actually f objective. For my convenience, I use it like f not. Here the triangle, I will just extract it from this point. This is capital H. Thus, UE is none other than FE, IVs and beta. Okay. Now I want to get two equations because since the angles are very small, we consider drawn big angles, but real case it is a very small angles, minute type of small angles. For convenience, we draw bigger angles. We know one thing, theta is nearly tan, actually radian theta is nearly equals to tan of theta, right? Hurry. I can rewrite this equation in the form of like what? Magnification of the final image at infinity is equals to tan beta over tan alpha. Very simple. Very simple. Right. What is tan alpha from here? Tan alpha is the opposite side over hypotenuse. So, what is it? H over F. Capital H over F objective. Equation number 1. This is equation number X. Right. From here, I can get another equation here. What is it? Tan beta is equals to capital H over Fe. Right. That's equation number 2. Okay. Now what I'm going to do is, I'm going to include these results in the equation X. Magnification of final image at infinity is equals to what? Tan alpha is going, beta is going to be H over Fe, H over Fe, divide by this part, H over F naught, H over F naught, cancel off. So finally, my final equation is going to be mv equals to infinity is equals to what? F naught comes up, so F objective over Fe. This is for the first case scenario. I will make a separate video for the second case scenario. I don't have any intention to lengthening this equation, video. Have a good look at. You have to take the distance of the separation of the lens. So L so I normally ask you students to remember always it will create the image at here. What? This one is unavoidable for any case of microscope, telescope, for anything. V objective is must, then UE. So love you, remember it is like love you. Say it loud, love you. See? L equals to V objective and V. It's similarly like love you. Okay. So this is how you create the final image at infinity. Simple. Telescope is very simple device that according to the mathematical derivation and complicated in application. Okay, let's see in the other part of this one. I will include that in the description, and watch my other videos and subscribe. And if you want to learn things very entertainingly, join to my classes. That's it. God bless you.